Hi, it's time to assemble something. All that coming up on Astro's Electronics Lab. Greetings, the Astro 30 here yet again with I hope it's going to be an exciting video. Well, we'll soon find out. I have in my hand a ESP or Elliott Sound Products P101 Revision C board. It's a 150 watt MOSFET amplifier into 8 ohms loads, and all the details to assemble this are on Rod Elliott's secure pages, so you need to actually have purchased a PCB from him before, maybe even this PCB, in order to assemble it. So in this video I'm not going to give you any component values. I'm just going to go ahead, assemble it, and just bring up some tips along the way. Now, looking at the PCB, it is very well produced. The silk screen is very self-explanatory. It gives you the component designators. Now, there's two versions you can build. You can build a low power version or a high powered version. The low powered version runs on plus minus 42 volts and the high powered version runs on plus minus 56 volts. He said that you can run it on plus minus 70 volts, but he doesn't recommend it. If you do, however, run it on the plus minus 70 volts, you're going to have to change a couple of resistor values in the biasing circuit over here. But that's all detailed on his construction page on the secure website for this particular module. The other thing with this module is the power transistor MOSFETs mount on the copper side of the PCB, the correct orientation around, of course, so that the metal face of the transistor is facing out this way, and solder it down on this side with the legs sticking up through this side. And there's a reason for that as well, because there's two capacitors that have to go across these P channel MOSFETs, because the capacitance at the gate is slightly higher than the N channel, or it's slightly lower, I can't remember. Either way, you have to put in a couple of compensation capacitors across the top of the component legs of the transistor, soldered from the top. I don't know why he just didn't put, like, you know, a through hole for the capacitors here, but he didn't. So what we should do now is have a quick look at his schematic, which is available on his public website, and I'm sure he won't mind me filming the screen for that, because I'm not actually stealing the article and publishing it somewhere else on another website and claiming it as my own. There'll be a link in the description to his public website project for this, and I'll also link him the PCB purchase page as well in the description. So if you want to purchase this PCB, you can. I believe the cost is around $23.95. And yeah, so let's have a look at the schematic. Okay, let's have a look at my enormous... No, let's have a look at Rod Elliott's schematic for the high fidelity lateral MOSFET amplifier. Now, before we get into that, what is a lateral MOSFET? Well, a lateral MOSFET is a MOSFET that is specifically designed for high fidelity audio. Plus they have the source pin in the middle, where usually the vertical MOSFETs, as the switching ones are normally called, have the drain as the center pin. Those are about the only physical differences. However, putting switching MOSFETs in this amplifier, as mentioned several times throughout this article, is not a good idea and cannot be done, because it will blow up. Now, looking at the schematic here, we've got an MPN input stage as a long tail pair here, formed by these two MPSA42 transistors. Now, these transistors have a massive 200 volt collector to emitter voltage rating, which is impressive. This is not the first time he's used MPSA42s in his amplifier designs. This is probably the second or third I think I've seen these transistors used. That has a current mirror at the top because it's NPN, so the current flow is completely different compared to a PNP input stage. Normally you have a current source up here. The current source is down here. followed by this transistor and this transistor here. Got our output over here and our feedback resistor here and our gain resistor here. We've also got bootstrapping from the output through this capacitor to the negative rail, so that improves the overall linearity and gain of the amplifier. I'm not going to talk too much about this because it is a bog standard design of amplifier. Now we're looking at the high powered version of this, which runs on plus minus 56 volt. There is a low power version where you don't have to include these resistors, and there's only one set of MOSFETs. Here we've got a set of xenodiodes and silicon diodes. Now the xenodiodes themselves protect the MOSFET in the case of overload, so we're not putting too much voltage into the gate, say like a short circuit condition. However, it would not be recommended to short the output of the amplifier. Let's just make that clear. So as we can see, there's no VBE multiplier or bias spreader. We've got our VAS transistor up here, and there's no current source except for this network here for that VAS transistor. Biasing is achieved by adjusting this variable resistor. The bias of this amplifier would be around the 25 to 35 milliamp quiescent current range. It shouldn't need to be any more than that. I will stress that the high power version is running on close to 120 volt DC, so extra care and attention has to be paid when working around DC voltages that high, because they can be potentially lethal. And just for reference, here is the low power version, which runs on plus minus 42 volt. It's the same topology, the only thing is the source resistors are missing, so you would replace them with wire links on the board. You don't have to, you can leave the resistors in there if you want to, and you only need one set of MOSFETs if you want to save a bit of money, but you can still put all 4 MOSFETs in if you want to on the low power version. It wouldn't make any difference to it. Let's get back to the construction. Now I sorted out the components in the box that Jeff gave me into a packet here where I've got enough components for one module. He didn't supply a few components. There was a couple of capacitors missing, the fuse clips, the fuses, and I can't remember what else. There was something else missing. Oh yeah, the trim pot that goes for the bias adjustment here. Oh, and the diodes were missing too, the 1N4004s. So now what am I going to use this module for? Well, his intention was, that's Jeff that is, was to build 2 of these into a monster stereo power amplifier, probably with a preamp attached to it. However, I'm not going to use it for that purpose. I'm going to use it for another purpose, but I'm going to leave you guys guessing as to what purpose I'm going to use it for. And no, it's not going into that speaker box which has got crap frequency response, which I've got to fix. It's going to go into another project. Ooh. Anyway, so without further ado, let's get on to assembling this thing, and I'll only take bits of information along the way. I'm not going to film the whole entire assembly process because it's going to be boring. Anyhow, let's get started. Alright, and I just looked at the invoice that this came with. This was purchased in December 2015. That's how long Jeff has had these boards knocking around. For, well, best part of 8 years. Okay, after that little math break. Now, I'm going to start assembly. That's actually got quite a bit of a warp in it, to be honest. Anyway, I'm going to start assembly with the obvious things like wire links. There's only 2. There's one here between the 2 transistors over here, and we need to run a wire, a link wire, insulated, just where it says C9 here, that little point there. There's a point here, another one here. Those 2 points there is where you put 2 PCB pins, bend them over to actually crimp the wire in, just to make it a lot neater when it's running around the board. Now be aware that's going across the positive rail, those PCB pins, so they cannot come into contact with the actual wire, so the wire needs to be insulated. So first I'm going to put the first wire link in over here. Then I'll deal with this wire. Alright, so the wire links in, I'm going to need a couple of PCB pins to make those two connections there. I'm also going to put a PCB pin at the input because I can use a header connector or PCB pin header connector on that PCB pin to get the input. But first I want to figure out how the hell am I going to bend these over at 180 degrees. Got it over, but I closed it up too tight. Which is now going to be a prick to get open. You bastard. Right, something like that will suffice. Focus. Yeah, something like that. Just enough to get the insulated wire through the middle, and then you can clamp it over with a pair of pliers. Now I've got to do that a second time. Then I can solder those two in first, and then I'll solder the input one in. Okay, pretty happy with that. Now I bent them first before soldering them, so I'm not putting stress on the PCB. Alright, and remember this is the positive rail after fuse protection, so make sure that the wire that is running up along through these clamps, as we're going to call them, is insulated. That one didn't quite fully go all the way down to the board, so I'll just fix that. Now it did. Excellent. Okay, now I can put the input one where it says in. You can put a JST connector there if you want to. I'm not going to. And I've made an executive decision here. I'm going to be using a 35 volt toroidal transformer because, funnily enough, Ultronics don't sell a 40040 in 300 VA. It's 35035 and 45045 respectively, which is odd, but alright, we'll go with that. And that's going to cost around about $156. So now I need to fashion up a piece of wire to go from that point where it says P ground up to where C9 is marked. I just happened to find a piece of green scrap hookup wire that was lying around, so I've stripped the ends, measured it out to roughly the correct length. Now I'm just going to tin the ends before soldering them in the board. I did say I'm not going to take too much video of this because, well, it's not really necessary. So now I can try and get that wire to come up a bit if I can. Where's my screwdriver gone? Like so, and I'm going to clamp over the PCB pin. So it's now clamped in position, except that one's crooked as hell. Well, it's not the prettiest thing in the world, but I'm going to say that it's, for all intents and purposes, clamped, but this one's just not. I'm just not happy with this one at all. Yeah, I'm not happy with that PCB pin. So I might actually take him back out because I'm going to end up wrecking the insulation. Alright, there we go, much better. I ended up redoing the wire because, well, I melted it. So I redid both PCB pins. What a pain in the ass. It's a bit longer wire than I wanted, but yeah, it'll certainly do the job. Anyway, moving back on to other components. The order I would do this in is I would do the small size resistors first, these diodes, and then leave the power resistors till last, as well as the trim pot. And then you can install things like capacitors, and finally the MOSFETs. But I'm going to do the resistors first, and then we'll come back. Okay, your mum. I've got all these low profile resistors soldered in. That one's standing up a bit proud. Anyhow, it makes it more awkward when the PCB pins are already in. But just make sure that with these xenodiodes and these silicon diodes, you don't get them inversed on the circuit board. It is marked ZD1 and ZD2 and D1 and D2 respectively. Do not mix them up, or else the circuit will not work. So the next course of action is, before I install any other components, I might just install these M205 fuse clips where they go. Just stab the desk, no worries. Didn't stab myself, so that's the main thing. So I'm going to need 4 of these. These come in a packet of 8, and it's JCAR catalogue SZ2018, by the way. It's 2, and I need another 2. If you follow the order I assemble it in, you should have a reasonably neat looking circuit board. Those two are stuck together, so I'll just put this one back. Maybe. I'm getting a collection of junk off to the right here. It means you've achieved something. I can't get that back in the hole. That's what he said. Might have to make the hole bigger. That's what she said. Get in there, you sod. Ah, you sod. Right, now I've got that out of the way, I'll put that to the side. Got to get these to separate. I don't know how they ended up like that, but there we go. Now, as most of you know, there's a little tab on one side of the holder. That's where the outer edge, most edge of the fuse sits up against, so they must face opposite from each other. They can't be like inward like that or facing the wrong way. I've had bugger all sleep last night, so this is really challenging for me to even talk. Now these are going to be a bugger to keep in there. I'm good, just ask me. Alright, so I'm going to solder, or just tack one in, and then I'll just maneuver it around until it's actually fully soldered properly, or fully seated properly I should say. Alright, let's see how we did. Yeah, look at that, not bad. Perfect. And that's what I meant by the little tabs. You see they face away from each other so that the fuse will fit in there properly. Putting it in the wrong way around is not really the end of the world. You can either unsolder it and resolder it, or you can just bend the tab out the way. It's better to do it right the first time though, however, because yeah, it just looks ugly otherwise. So that one, just retouch that one, retouch that one. Okay, that's one fuse holder installed. I've just got to do the same again for the other one, and then we can move on to something else. Right, with the fuse holders in, I'm going to put the large, what are they? Source resistors in. If you're doing the low powered version, you don't need to install them, you just put wire links in instead. You can use 5-watt devices if you want. Circuit calls for 2, but either version I would still use them. There's no harm in it. So I'll just measure out how far I've got to bend the thing. And these will want to mount just prior to the board to allow some air to flow through. So because the fuse holders are in, it makes it kind of easier to keep the gap. And I'm putting the bands of the resistors around the same way so the electrons don't fall out. No, it's just for readability. It's better. It's like a dress code for PCBs, if you like. Some of these pads are a bastard to solder to, most likely because of the amount of copper that's connected to. But that's alright. Just requires a little bit more heat and patience. That's two resistors done, so I'll just cut off my excess. He really likes to promote himself, doesn't he? He's got an ESP logo somewhere on the board, copper side. I can't find it now. Oh, right at the top here. And he's got Elliott Sound Products written in text there. But I guess in reality I do the same thing. Now that's what I meant. I'll turn it that way so you can see it better. Those haven't been soldered, so we'll ignore them. That's about a good gap to have between those resistors. So I'll just finish up doing the other two, and there's another 2 power resistors to put in, and yeah, we'll come back. Well, it's coming together nicely. I really should probably put the spade terminal connectors in before I can't even do it anymore. That might be a good idea. So I'll go find where some spade terminals are. I've put the ones that Jeff sent me away, but I've got another pack somewhere. I'll have a root around and see if I can find them. Alright, I found them. I need 4 of them. So there we go, 4 of them. Put that back where I can't find them. Now, these may be a little tight to get into the PCB. They indeed are. Which, at least they won't fall out. Can I squeeze them down in, or do I have to enlarge the holes? Alright, let me play around with this. I'm going to have to enlarge the holes. Annoying. Yeah, I don't think I'm going to be able to do it like that. I was hoping not to have to unpack the drill just for doing one thing. That's backwards. Just be careful not to drill through your finger. You'd think by now that Rod would have changed this. It was designed for PCB pins though. Yet his photograph does say show spade connectors. Okay, they're probably a bit too large now, but at least they should fit. Let's get rid of some crap. Okay. Yeah, much better, but it's a bit loose now, but I'll get them soldered in and straightened up. Okay, a little bit painful, but they're soldered in now. That was a bit, how you doing? Anyway, take note of the orientation to go that way and to go that way. So now, what we can do next is play with ourselves. No, I think I'll put in the small signal transistors. Be mindful of which transistor goes where. Now I've just done 2 signal transistors, and these pads over here, this one and this one, are very close together, and it's very easy to bridge them, so make sure you check your work thoroughly before powering this up, because a solder bridge across the transistor is going to cause the circuit not to work. So, and these pads for the signal transistors are very, very close together and fine, so it's very awkward to get a soldering iron in there. Anyway, moving on. And be sure not to mix the transistors up, because there are 3 different types. MPSA 42s, BC549, and a couple of BC548s. So don't mix them up. I might cut those 2 leads off first before trying to solder the base. Well, I assume that's the base connection on that transistor. I don't know the pin out of the MPSAs, to be honest. Alright, they're soldered in, so now I can move on to capacitors. I'm going to start with the ceramics first, and MKTs and stuff like that. And unfortunately that's where we're going to have to leave the assembly procedure for today. I've decided to split this up into two parts because the video is getting on to almost the hour mark, because there's a lot of information. I haven't filmed or done the testing procedure yet, but that I can guarantee you is going to take at least 10-15 minutes of video time, because there's a lot of information I need to convey about the testing procedure. But that will be filmed as soon as I've moved residences, which I'm doing on this coming Sunday. So after I've got myself set up, we'll get into testing it. And when that video becomes available, you may see a link up here. Or you may be lucky and see one over here. Anyway, I'm the Astro 30. If you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and become a Patreon supporter for as little as $1 a month. Links are in the description, guys. Anyway, this is the Astro 30 saying see ya. Have a great day.